In this section, we're going to take the next step to developing our application. We want to allow users to upload music to share with others on the application. Uploading files is a shared responsibility between the client and the server. It's important we take the time to understand what each side is responsible for. Our job as front-end developers is to send the file to the server. The server is what takes care of the majority of the work. The server takes care of validating the upload by checking the file type. It is possible to spoof file extensions, so being able to check for this is important. The server will also take care of uploading the file to the correct directory, storing it in a location purposely meant for uploads only. File permissions are another job for servers. It's an optional step but recommended. Some files should be limited to a few select authorized users. Lastly, the server is responsible for creating the API that the client can use to upload files. The client is what will take care of presenting the file to the user. This can be in the form of an image, direct link, or in our case, a music player. We're using Firebase for our backend. Fortunately, it comes with everything we'll need to handle file uploads. This service will save us a lot of time. Uploading files with JavaScript is completely optional. Here's an example of how you can perform file submission with pure HTML. There are 3 requirements for submitting a file with HTML. The encoding type must be set to multipart. There needs to be an input with the type of file. Lastly, the forms action needs to be set to the URL where the file will be submitted to. There are additional attributes you can set, but those are optional. From there, the browser will take care of the rest. No JavaScript is necessary. For this course, we will be handling the form submission with JavaScript. It'll allow us to handle the user experience and prevent the page from refreshing. We'll even be able to handle multiple file uploads at once. Switching over to our app, the UI is very different from the pure HTML solution. On the left, we have a drop zone where the user can drag and drop files. If files are dropped on the box, it'll initiate the upload process. Under the drop zone are progress bars to let the user know the status of their upload. It's a more complex solution, but nothing that we won't be able to handle. I'll walk you through every step of setting this up. Alternatively, we may need to provide a more basic solution because not every user can drag and drop. Backward compatibility is something we should consider. I'll show you how to deal with that in this section. Firebase is our solution for a backend. We've used it for storing the user's data so far. It comes with a feature called Cloud Storage. This solution is the service that provides hosting for user-generated content. We're going to use it to store the user's file uploads. We'll revisit it later in this section. In this lecture, we're going to start by preparing the component. We're going to be writing a lot of code for uploading files. It would be a good idea to separate this logic into a separate component. Let's open the Manage component in our editor. The upload UI is inside the Manage component file. The static template comes with 2 columns. I've folded most of the code so it can be easier to focus on the columns. You can find the columns by searching for the div tags with the classes call_span1 and call_span2. The HTML for the upload UI is in the first column. We're going to move the contents of this element into a separate component. There's a lot of markup inside, so it makes sense to separate it from the Manage component. It'll make things a whole lot cleaner. First, we'll create the component. Inside the Components directory, create a file called upload.vue. Scaffold the file with the template and script blocks. In the exported object, we're going to assign the component a name. We'll call it upload. The next step is to copy the template. Go back to the Manage component file. Inside the div element with the class call_span1, cut and paste the entire element from the Manage component to the Upload component. The last step is to import and register the component. We're going to register it locally because it's going to be used once. We don't need it to be globally available. Back in the Manage component, import the Upload component. I'm calling the component App Upload. This name is to prevent any conflicts with existing HTML elements or components registered by third-party libraries. In the exported object, define the components property with the App Upload component registered as one of the components. Lastly, insert the App Upload component into the first column. This location is where we previously cut the HTML for the upload component. Let's view the Manage page in the browser. Everything will look the same as before. To verify the HTML is stored in the component, we can use the View Developer tools to check the hierarchy of components. The App Upload component is nested inside the Manage component. It'll even be highlighted inside the browser if you hover your mouse over the component name. That'll do it for now. In the next lecture, we'll begin wiring in the logic for the component. In this lecture, we're going to begin the upload process by using drag and drop events. The first step to creating the uploader is to add drag and drop support to an element. In the Upload component template, search for a comment that says Upload Dropbox. Below this comment, we'll find an element for dropping files on. We want to allow users to drop files onto this element. Once a file has been dropped, we will initialize the upload process to Firebase. Adding drag and drop support can be done by listening to several events. On the element, listen for the following events: drag, drag start, drag end, drag over, drag enter, drag leave, drop. We're listening to a lot of events, but it's necessary to listen to them because we may experience unexpected behavior if we don't account for them. These are native browser events. They're not specific to Vue. Let's review each of them. The drag event is emitted when the element it's applied to is being dragged. For example, if I were to click on the element in the browser and begin dragging it, this would trigger the event. The drag start event is emitted when an element is starting to be dragged. The drag end event is emitted when an element is no longer being dragged. The drag over event is emitted while the user is hovering something over the element the event is applied to. The drag enter event is emitted when the user begins to drag something onto the element. The drag leave event is emitted when the item that was previously being dragged over the element is no longer being dragged over it. Lastly, the drop event is emitted when the user has released the element or text that was being dragged. This event can be triggered when the user releases their mouse or by pressing the escape key. We will want to apply event modifiers to all of these events. We'll apply the prevent and stop modifiers. The modifiers will prevent unexpected behavior when a file is dropped onto an element. By default, most browsers will load the file in the browser, depending on the file type. This behavior will move them away from the app. We don't want the user to be redirected away from the app when they drop a file. We want to handle what happens when a file is dropped. Using the modifiers will stop the default behavior. Let's test if this works. Switch over to the browser. For this demonstration, I'm going to drag and drop an image file. If I were to drag and drop a file anywhere on the page but the uploader, the browser will load the file. This is the default behavior. Going back, I'll drag and drop the file again, but this time onto the uploader. After dropping the file, nothing happens. The page doesn't change like last time. It's important that you prevent the default behavior and stop the propagation so that you can handle what happens next. There is one issue with this so far. If I hover my mouse over the element, the box will turn to green. The hover effect works fine until we attempt to drag files over the element. The hover effect doesn't get applied. We'll have to use JavaScript to achieve the hover effect. It's an excellent way to indicate to the user that we're aware they're trying to drag and drop a file onto the uploader. Back in the editor, we're going to dynamically bind the class attribute on the upload Dropbox element. We're going to bind the following classes as one property: BG Green 400 border green 400 border solid. These classes will apply the hover effect we wish to achieve. We want to dynamically bind this class if the user is dragging something onto the element. We'll want to remove them if they move away from the element. Since we're dealing with binding classes on a conditional basis, we'll want to use the object syntax. The value for the property will be used as the condition. We're going to set this to isDragOver. The isDragOver property doesn't exist. We'll want to define this property in the component. It'll be used to keep track of if there's a file being dragged over the Dropbox. Define the data function inside the component. Inside the data function, we'll define the data property. Its initial value will be false. By default, these classes won't be applied immediately. We want to apply them if a file is hovering over the element. By the way, we're creating this as a property in the data object instead of the state because this is a value that only affects the current component. It's perfectly fine for some data properties to be defined inside a component. Scroll back up to the events we added to the Dropbox. We're going to set the isDragOver data property to true if the events drag over and drag enter are emitted. Both events are emitted when a file hovers over the element. We'll want to add the class during these events. Next, we'll set the data property to false in the events drag end and drag leave. Both events are emitted when the user stops dragging the file over the element. By setting the property to false, the class won't be applied to the element, thus removing the hover effect. That will take care of binding the class dynamically. If we did everything right, then we should see the upload Dropbox change color. Go back to the browser. Let's try dragging some files over the Dropbox again. Surely enough, the element changes color if we're dragging files over it. It still isn't perfect yet. If I were to drop my files onto the element, the color stays the same. This is because the browser will emit the drop event if we were to drop something on the element. In this case, it would be the file. We'll want to remove the class when the file is dropped on the Dropbox. Also, we want to begin uploading the file. Back in the editor, we're going to update the drop event in the template block to call a method. The method name will be called upload. We aren't going to directly change the data property in the expression as we did with the other events. We'll do that inside the method because we want to do more than remove the class. We'll want to grab the files and initialize the upload process. We'll define the methods property in the exported object. Inside it, define the upload method. Inside the function, we'll set the isDragOver data property to false. That will take care of removing the color effect after a file has been dropped onto the element. Save your changes, then proceed to the browser. Try adding a file onto the Dropbox. After dropping a file onto the element, the class is removed because the color fades away. Fantastic! We've successfully added drag and drop support to the element. The next step is to begin handling the file upload. We'll look at that in the following lecture. In this lecture, the objective is to grab the file from the drop event. We'll prepare the file before initiating the upload. Let's jump right into it. We'll continue working in the upload component. The first thing we need to do is grab the file that was dropped onto the element. The drop event we're listening to will pass along the files that the user dropped. We can retrieve the files by using the event object. In the template for the upload component, pass the event object to the upload method. Vue creates an object called event. We can pass it to our methods if we choose to. The event object is the same object you would come across in any other JavaScript event. Vue will call it event so that you can pass it to your methods. Down below in the upload method, we'll accept the event parameter. Inside the function, we're going to log the event object. We want to check out what's inside before we move on. Next, we'll switch to the browser with the console opened. Drag and drop a file onto the uploader. Inside the console, the event object is logged. Opening its contents will reveal a long list of properties. The one property we'll want to focus on is the data transfer object. This object will contain the contents of the files transferred. There's a property called files. It's an array of files that were dropped on the element. However, if we look at the files property, it'll be empty. This output is very mysterious because we did everything right. You may assume there's an error in our code, but it's actually not our fault. For one reason or another, Chrome will not log the files unless you access the files directly. Let me show you what I mean. Let's go back to the editor. We're going to create a variable called files. It'll be set to event.dataTransfer. Next, update the log with the variable. Going back to the browser, we'll drop a file onto the uploader again. Just like magic, the files property is filled with information related to the file dropped. This error is a gotcha with Chrome. If you're trying to debug drag and drop operations, you need to access the properties directly to see their values. Simply logging the object, in general, will result in an empty array. It's a weird bug in Chrome, but I thought I'd let you know just in case. Moving forward, we can begin to use Firebase to start the upload process. Firebase allows us to upload multiple files in parallel, but they need to be passed in one at a time. Here's what we'll do. We'll loop through the files in the event. In each iteration, we'll send the file to Firebase. Firebase will send back a response which we'll handle. This is where things get tricky. The files array is actually an object. It may look like an array because the keys are numeric, but it's not an array. We don't have access to the looping functions that come with the array object. We'll need to get creative by converting it into an array. We'll update the variable definition by wrapping the event.dataTransfer.files property with square brackets. Then, we'll add the spread operator before the value. This syntax is a clever way of converting an object to an array. We're spreading the object properties into an array. This will allow us to use the array methods. We'll call the forEach function on the files array. Pass in a callback function. The callback function will receive the file in each iteration. There are 3 parameters, which are the file, index, and array. We don't need all 3. We're going to add the file parameter. Next, we'll want to perform validation on the individual file in the loop's current iteration. We want to check the file type. If the user attempts to upload a file other than an audio file, we'll reject the file. Validation can be performed in Firebase, but as an extra precaution, we'll perform it on the client side. Inside the function, create a conditional block. The condition will be the following: file.type does not equal audio/mpeg. I quickly want to go over MIME types. A MIME type is a label to help identify the type of data in a file. They're similar to extensions, except they can't be changed easily. It's more practical to check for a file's MIME type than it is to check for the extension. MIME types are formatted by their type and subtype. A slash separates them. The type is the general category a file belongs to. This is why you may see some MIME types with similar values. Audio files are assigned under the audio category. The subtype is the specific type of file. This part of the MIME type is where most MIME types differ from one another. I've provided some examples of MIME types. For this course, we're going to be checking if the file is an MP3 file. Other audio file types can be used. In the resource section of this lecture, I provide a link to a Wikipedia page with information about what audio types are supported in which browsers. MP3 files are generally supported in most browsers. Some browsers will not support certain file types due to patents or licensing issues. We'll keep it simple by limiting support to MP3 files. Back in the editor, we want to check if the MIME type isn't audio/MPEG. If it isn't, we'll return the function. This return statement will end the current iteration of the loop. If the user makes it to this point, we can begin to upload the file to Firebase. We'll start handling the upload in the next lecture. In this lecture, the objective is to upload the file to Firebase. The Firebase Cloud Storage Service is enabled in Firebase already. We're using the SDK to communicate with the Firebase application. Open the Firebase file for a moment. At the top of the file, we're importing the services we want to work with. We can't use the cloud storage functions unless we're importing the storage module. Import the Firebase/storage module. Next, we'll export the storage service so that we can use it in our components. Below, we're defining a couple of variables that we're exporting. We'll add to this by defining a variable called storage. It'll be set to firebase.storage. The storage function we're calling will tell Firebase that we'd like to start using its storage services. Any tasks related to using the storage can be found under this method. The last thing we'll do is export the storage object. This object will expose the cloud storage functions to our components. Go back to the upload component file. The next step is to import this object in the upload component. The first step to using the storage service is to create a reference. I'll explain in a moment what a reference is, but let's start with the code first. Create a variable called storage reference. Set it to the storage.ref method. We're creating a reference to the storage. The reference represents the path in our storage, aka the bucket URL. It's the same URL you'll find in the configuration object for Firebase. I'm going to add a comment afterward with the URL to show what the method will return. We need to create this for Firebase to know where to upload the file. We can instruct Firebase to upload the file to a subdirectory by passing in a path to the reference function. For example, if we passed in songs, then Firebase will upload the file to the songs directory. It's always a good idea to store the file in a subdirectory to keep things organized. We're not going to use the reference we created. It's considered good practice to create a separate reference for subdirectories. This way, we have a reference for the root storage and another for the subdirectory. After the root reference, we'll create a variable called songsReference. We'll set it to the storageref.child method. The child method will create another reference. The main difference between the child and reference function is that the child function will create a path relative to the parent reference. In this example, the parent reference is the storage reference. We're creating a separate reference specifically for the audio file the user is uploading. Unlike last time, we'll want to pass in the directory we'd like to upload the song to. The path will be songs/file.name. This path will result in a reference pointing to our bucket with the path attached to it. I'll add a comment to show an example. This might seem redundant. If we wanted to, we could have defined this as one reference. so why didn't we do that? It's generally good practice to have at least one root reference and an additional reference for each file you plan to upload. This is the pattern you will see implemented in most applications, even if you're uploading one file. It keeps the code clean and scalable. By creating a root reference, you can easily create more references without having to call the same methods repeatedly. In this example, we're storing MP3 files in a directory called songs. In addition, we're using the name of the file. Every file object comes with a property called name that represents the file name. The purpose of creating a reference is to tell Firebase where we'd like to store the file. The next step is to upload the file to Firebase. Call the function songsReference.put. Every reference comes with a method called put. This function will initialize the upload process. The put method requires the file we'd like to upload. We'll pass in the file variable that comes with every iteration of our loop. We're finished with writing the code for uploading a file to Firebase. Let's try giving things a test. In the application, try uploading an MP3 file. If you want, you can try uploading a file that's not an MP3 file. It should reject the file. We won't know for sure because we haven't handled the response. We'll take care of that in another lecture. We can verify the upload by going to the Firebase console. Open the Firebase console in your browser. On the sidebar, navigate to Storage. In the Firebase console, you will need to refresh the page to view the files uploaded to the bucket. Great, the files have been successfully uploaded to Firebase. If you upload a file that's not an MP3, you shouldn't see it in the storage. We're finished with uploading the file. The user doesn't know if the upload was a success or not. In the next couple of lectures, we'll work on handling the response. In this lecture, we're going to review the rules for the Firebase storage service. There are some modifications I'd like to make before moving forward. You can find the rules under the Rules tab in the Storage section of the Firebase console. You'll come across a page similar to mine. The rules may look familiar to you because they use a similar syntax to the database rules. Let's run through them line by line. The first line is setting the version. Different versions support different syntax, rules, and features. Version 2 is the latest. It's the version we'll be working with in this course. The next line is selecting the service the rules will apply to. It's selecting the Firebase.storage service. This service is followed by a pair of curly brackets. Anything inside the curly brackets is grouped together. We're able to apply some rules or make some further selections. Afterward, we're using the match keyword to instruct the rules to select any bucket in the Firebase application. The bucket variable is a placeholder for the current bucket being accessed. Firebase allows you to create multiple buckets, but the free version limits us to one. Another match is made for any paths inside the buckets. You can think of both match statements as wildcard selections. Lastly, we're adding rules to both the read and write permissions. It's saying to reject requests where the user isn't authenticated. There's one thing I want to note about this. We didn't have to tell Firebase that the user was authenticated. The SDK will take care of sending the token to Firebase if the user is authenticated. There wasn't anything we needed to do on our part. That's the beauty of using the SDK. It's able to do things like this. Earlier, I stated that I wanted to modify the rules Firebase has provided us. There are 3 changes we're going to make. First, we want to allow anyone to access the files. Visitors should be able to listen to music without having an account. However, we want to continue to limit upload permissions to authenticated users. Secondly, we want to check the file type. We performed validation on the client, but it doesn't hurt to perform it on the server too. The third thing we'll check for is the file size. We want to limit how large a file can be because storage space is limited. A single file can theoretically increase the bill. Setting a file size limit can prevent that from happening. Server validation is something to be left to the backend developer of your application. This part isn't necessary, but if you plan on using Firebase for your applications, this may be nice to know. If you don't plan on using Firebase, you can skip this part and move on to the next lecture. In the rules, we're going to separate the read and write rules. Currently, they're combined into one. The read rule will be updated to allow anyone to read the files. We aren't too concerned with the contents of the files being uploaded. We won't be storing files that require restrictions. You can add rules for that if you'd like, but it's not necessary for this application. For the write rule, we want to continue to check if the user is authenticated. We're going to add on to this by checking for the type and file size. We can add additional conditions by using double ampersand symbols. The second statement will be the following: request.resource.content-type == audio/mpeg. The request object refers to the request being made to the Firebase storage service. We're accessing the resource object, which represents the file being uploaded. We're using the resource to grab the content type of the file. This object is where the MIME type is stored. We're checking if its value is audio/mpeg. This condition takes care of checking the file type. The next thing we'll check for is the file size. Add another condition to the write rule. The condition will be the following: request.resource.size less than 10*1024*1024. We're using the resource object again. It has another property called size. It's the size of the file. The size is measured in bytes. We're checking if the size is less than the equation on the right. The equation we're using will calculate the maximum upload size in megabytes. There are 1024 bytes in a kilobyte, and there are 1024 kilobytes in a megabyte. This condition will limit the maximum upload file size to 10 megabytes. If the file is larger than that, then the file will be rejected. If the file is rejected, Firebase will throw an error. We'll handle errors in a future lecture. If the three conditions return true, then the file will get uploaded. There's one cool trick I want to show you before we publish the changes. The second condition is checking for the file type. In some cases, you may want to allow multiple types. Writing each type can be cumbersome. Firebase has a function for checking multiple types if they're in a similar category. Instead of checking the type, we can run a function on the content type property called matches. This function allows you to pass in a type with a wildcard. For example, we can pass in audio/star. This is a custom function defined by the Firebase API. It'll check if the type is in the audio category. The asterisk character acts as a wildcard. It'll allow for any subtype. For this course, we're going to be dealing exclusively with MP3 files. I'm going to revert this back to the original. If you would like more information about these values, you can check out the link I provided in the resource section of this lecture. The documentation page will provide the details you'll need to secure files in your bucket. Back in the Firebase console, we're going to publish the rules. Make sure your rules match mine. The rules have been published. We should still be able to continue to upload files. Try testing out the uploader. We won't be able to see if the upload was a success because we haven't handled the response. Switch to the console to check the storage for the file. The file was successfully uploaded. Great. We're able to continue uploading files, but with additional restrictions in place. In the next couple of lectures, we'll continue working with the uploader. In this lecture, we're going to make the progress bar functional. We want to be able to let the user know if their upload is in progress, a success, or a failure. Accounting for these three scenarios will provide for a better user experience. On the page, we have a couple of dummy progress bars under the upload box. The progress bars are built with Tailwind classes. We're going to convert this progress bar from a static element to a dynamic one. The first thing we'll do is listen for the response from Firebase. we're going to continue working on the upload function we defined in the upload component. The put method we called to initiate the upload will return an object. This object will emit events we can listen to during the upload. If we want to listen to the events, we'll need to assign the object to a variable. The name of the variable will be called task. Firebase calls the object returned by the function a task snapshot. Right after creating the task variable, we're going to call the on function from it. This function will let us listen to events on the object. The name of the event we'll want to listen for is called state changed. The state changed event will get emitted on 3 occasions. It'll let you know the progress of the upload, if the upload failed, or if it succeeded. They're the 3 scenarios we'll want to handle. We can pass in 3 functions to handle each one. The first function we pass in will be for the progress of the upload. We'll pass in an arrow function. We have access to one parameter called snapshot. We'll accept the parameter. The snapshot object contains information about the current upload. In the resource section of this lecture, I provide a link to the Upload Files documentation page for Firebase. On the sidebar, there's a link to a section called Monitor Upload Progress. Click on it. This part of the page documents the properties you can find in the snapshot object. In the second table, you'll find the list of properties. There are 2 properties we'll want to use. They're the bytes transferred and the total bytes properties. The bytes transferred property represents the number of bytes transferred so far. The total bytes property represents how many bytes are expected to be transferred. Both properties will help us calculate the progress of the upload. We can display the progress to the user by adjusting the width of the progress bar. This is what we'll do in the function. Let's switch back to the editor. We're going to define a variable called progress. It'll be set to the following value: snapshot.bytestransferred / snapshot.totalbytes star 100. This is a calculation to get the percentage of how much has been uploaded so far. We can use the percentage to set the width of the progress bar. Let's prepare the progress bar in the template. In this template, search for a comment that says progress bars. Under this comment, there are 3 dummy progress bars. Remove 2 of them. We only need 1. Here's what we'll want to do. We want to loop through the number of uploads and display their progress. Currently, we don't have an array to represent how many uploads have been made thus far. In the data object, create a property called uploads. Set it to an empty array. If a new upload is initiated, we'll want to push it into this array. Back in the function, we're going to call the push method on the upload array. Push the upload before we listen to any events on the task object. We're going to push an object with 3 properties. The first is the task object. We're pushing this in because we may need to reference the task outside of the loop, for things like canceling the upload or retrieving data from it. It makes sense since it contains info about the upload. The next value we'll want to push is the current progress. The initial progress will be 0. The last property we'll want to push is the name of the file. Create a property called name. We'll set it to file.name. The reason we're adding the name is because the progress bar has the name above it. We'll need to store the name of the file if we want to display it. The array is ready. We can update the template to loop through the array to display the progress bar. Scroll back to the progress bar in the template. On the div tag with the class MB4, add the v4 directive to it. The expression will be the following: upload in uploads. It's important we assign a key to prevent strange behavior. Bind the key property to upload.name. We'll start from the top and work our way down. There's a comment that says file name. Below this comment, there's a div tag, which is the container for the file name. Replace the static text with the expression upload.name. Next, there's a comment that says inner progress bar. Below this comment is a div tag. We're going to manipulate this element by binding its width. First, let's remove the style attribute. Afterward, we'll bind the style attribute to an object. We'll set the width property to the upload.currentProgress property with a % symbol. This binding should give us the desired effect. Moving on, we're going to change the color of the progress bar. We can use a Tailwind class to change the color. We're going to bind the class attribute to the BGBlue400 class. The progress bar will always be the same color. We're finished with the progress bar. In the next lecture, we'll look at how we can make the progress bar more dynamic. In this lecture, we're going to make the progress bar more dynamic. We'll continue working in the upload function in the upload component. We'll want to update the progress bar whenever the state changes. In the state changed event, we have a function that runs whenever progress has been made to the upload. We'll update the property here. We've taken care of calculating the progress. The next thing we need to do is update the current progress property. The problem is we don't know which object to update because there can be multiple objects in the array. We need to save the index after we insert it so that we know which object to update. We can save the index by assigning the value returned from the push function to a variable. We'll call it uploadIndex. The push function will return the length of the array after the object has been pushed into it. That's not exactly what we want. We want the index. Luckily, we know that the object will be inserted as the last item in the array. We can subtract 1 from the length to get the index for that latest item in the array. We can use this to update the correct object. Inside of the arrow function, add the following. This.uploads uploadIndex.currentProgress equals progress. It's important that we're using an arrow function. Otherwise, we won't be able to use the this keyword because it's not bound to the component's instance. That should do it. Save your changes. Then, go ahead with uploading a file. I recommend uploading multiple MP3 files to test if the progress bars get updated individually. We're able to get the desired effect we were aiming for. Each bar is correctly representing the upload being made. It works great. The objective was to show the progress on each individual upload. We had to store the uploads by creating an array in the data object. Up in the template block, we looped through the uploaded items in the array. We added an expression for displaying the name. The width property for the progress is being dynamically bound to a property called currentProgress. Down below in the upload function, we attached a listener to the state changed event. It's an event that will get emitted whenever the upload has progressed, been canceled, or was successful. Inside of the function we passed in, we calculated the progress by using the snapshot object. The snapshot object represents the current status of the upload. We then used the calculation to update the current progress property corresponding to the object that represents the current upload. We couldn't have done that if we didn't store the index. We accomplished that by storing the value returned by the push function -1. We are not finished yet. We need to handle the upload if it fails or is a success. We'll do that in the next lecture. We're going to improve the progress bar to let the user know the status of their upload. There are 3 steps we're going to take. First, we'll change the color of the progress bar. Secondly, we'll change the color of the file name. Lastly, we'll add an icon to indicate that the upload was a failure. The progress bar will need to be more dynamic. Since there's going to be multiple progress bars at any given moment, we'll need to add more properties to each upload object to keep track of these values. We'll need to modify the object we push into the uploads array. We'll add a property for the color of the progress bar. We'll need to store the value as a property in the object. Create a property called variance. Set its value to bgblue400. We're using the bgblue400 class because that's the initial class we used. We'll want to change this when the upload is complete. Next, create a property called icon. Set it to FAS, FA, spinner, FA, spin. The template we're using uses an icon set called Font Awesome. In the resource section of this lecture, I provide a link to the icon set. If you're not familiar with the icon set, then that's fine. The icon set isn't hard to use at all. It can be added to an application by loading a single CSS file. Afterward, you can load an icon by assigning a special set of classes to an element. We're using the free set of icons that come with Font Awesome. There's a premium set available. Feel free to check those out if it's something you'd like to use. Back in the editor, we're setting the icon property to the CSS classes that will add a spinner and animate it. You'll see what it looks like when we add the icon to the template. The next property we'll want to add is for the color of the text. Tailwind comes with some classes for changing the color of the text. These colors will match the colors of the progress bar. Create a property called text class. Set it to an empty string. We won't change the color of the text while the upload is in progress. This is why we're setting it to an empty string. The color will change when the upload was a success or failure. This is more of a design decision, but you can always change the color if you'd like. In the resource section of this lecture, I provide a link to the color text classes. Feel free to check out these classes after finishing this lecture. We've added 3 additional properties to the upload object. They'll help us change the appearance of the progress bar based on the status of the upload. The next step is to bind the properties to the template. In the template block, we're going to bind the values to the progress bars. First, we're going to update the class binding to the upload.variant property. Next, we'll add the icon. We've already loaded the Font Awesome CSS file in an earlier lecture. We can load an icon by adding an element with the CSS classes. You can refer to the documentation for the names of the icon classes. We'll add the icon before the file name. Create an I element. Bind the class attribute to the upload.icon property. Afterward, we'll work on changing the color of the text. As a reminder, we don't want to change the color initially. The color will change after the upload is complete. The file name is inside the div tag with the class font bold text sm. On this element, bind the class attribute to the upload.textClass property. Vue will take care of merging the class attributes. If we did everything right, we should see the same thing as before with the addition of the icon. In the browser, upload a new file. The progress bar is fully functioning with the addition of the spinning icon thanks to Font Awesome. The main difference to what we had before is that most of the properties are bounds. We'll be able to change them based on the state of the upload. Let's check out the upload component in the Vue Developer Tools. If we were to view the upload component's data, we would find the upload array we created. We can even verify that the task object has been added to the object. Looking inside, we'll find methods and properties about the current upload. We'll handle the state of the upload in the next lecture. In this lecture, we're going to handle the upload if it fails or succeeds. We're going to change the properties in each upload we pushed into the uploads array. In the upload function, we listened to the state changed event. We can pass in 3 functions to handle different situations. The first function is for handling the progress of the upload. We'll work on adding the other 2 functions for handling the error and success of the upload. we'll pass in two additional arrow functions to the event listener. The two additional functions are optional. If they're passed in, Firebase will call them based on if the upload was successful or not. The second function will be used for errors. It can have one parameter called error. The third function will be called if the upload was a success. There aren't any parameters we can add. That's perfectly fine. The task object stores a copy of the current snapshot. It's the same snapshot object passed into the first function. It'll provide us with information about the upload. We're going to start things off by handling the error. There are many ways we can approach this, but I want to keep it fairly simple. We can begin to change the values in the functions we created earlier. Scroll down to the second function we passed into the event. This is the function that will get called if there's an error with the upload. We'll want to change a lot of the values stored in the object related to the upload that got an error. First, we'll want to change the variant property to bgred400. We're using the upload index variable to get the correct object that received an error. We're changing the variant to danger because that will give us a red color. Next, we'll want to change the icon. The name of the icon we'll want to use is called FA Times. This set of classes will give us an X icon. If you're curious about where I'm getting these names, you can go to the Font Awesome site and click on the Icons menu link. You can filter the results on the right. I recommend using the free filter if you plan on using the free version. I found the icon by typing error, which gave me the times icon. On the individual icon page, there will be an example on how to use the icon. Font Awesome's simplicity is what makes it a favorable icon set for your applications. Back in the editor, we're going to change the color of the text next. Update the text class property to TextRed400. The TextRed400 class will change the text color to red. It's another way we can indicate an error has occurred. The very last thing we're going to do is log the error object. We're not going to use the error object, but it is worth checking out what we get. Before we can test the error, we'll first need to make it easy for an error to be thrown. We'll navigate to the Firebase console in another tab. We'll want to modify the storage service rules. One of the conditions we created will limit the maximum upload size. We'll change this to set the upload limit to 1 megabyte. Firebase will throw an error if the file size is bigger than 1 megabyte. In our application, upload an MP3 file that exceeds the file limit. After a while, Firebase will throw an error. Our second function will run, which will change the progress bar completely. This is the exact behavior we were hoping to achieve. Open the console in the developer tools. We logged the error object in the function. Upon inspecting it, we are provided with a couple of values. We're even provided a basic error message we could use on the front end. Just in case you wanted to create your own message, you could use the code they provided. The code property will tell you exactly what went wrong. We can take the UI a step further by checking the error code and displaying an appropriate message to the user. In the resource section of this lecture, I provide a link to the list of error codes you can receive. There are a lot of reasons as to why an upload may fail. We won't be going as far as to check for every error. We'll just change the look and feel of the progress bar. That'll take care of the error. I want to begin changing the UI if the upload was a success. It'll be a very similar process to the error. Before we do that, we'll want to revert the rules. In the Firebase console, set the maximum limit to 10 megabytes. Be sure to publish the changes for them to take effect. Switch back to the editor. We're going to copy the properties we created in the second function and paste them over into the third function. The third function is called when the upload is a success. we'll want to change the same properties we did in the second function, but with different values. We'll set the variant property to bggreen400. That'll change the progress bar to green. The icon will be set to FA check. That'll give us a check mark. An icon is usually associated with success. The text class property should be set to textGreen400. That'll change the text color to green. We'll leave the animate property to false. The reason is the same as before. By stopping the animation, the user will acknowledge the upload is no longer in progress. Let's give things a test. Go ahead with uploading a file. The upload was a success. It's been indicated by the change in UI. We are now able to change the UI based on if the upload was a success or failure. We were able to do this by creating properties representing the current status of the upload, binding those properties to the template, and then changing those properties in the appropriate functions. We've completed the task for this lecture. In this lecture, we're going to store the file data in the database. We're able to store the file in the storage successfully. However, we don't know who uploaded the file. There is additional information we'll want to associate with the file. We'll use the database to store additional information about the file. We're going to continue working in the upload component file. Specifically, we want to store the data in the database if the upload was a success. There isn't any point in storing the data if the upload was a failure. We're going to add the code in the third function of the stateChanged event. We'll store the data before we update the progress bar. Even though the upload is finished, we're not finished with storing the data. We don't want to let the user assume they can exit out of the application when we haven't saved the data yet. It makes sense to display that information last. We're going to start by creating an object that will represent the data we'd like to store in the database. We'll create a constant called song at the very start of the third function. There are a couple of things we'll want to store. First, we want to store the ID of the user who uploaded the song. Information about the user can be retrieved through the authentication service. We'll need to import the authentication object from the Firebase configuration file. At the top of the script block, update the import statement to retrieve the authentication object. Back in the song object, we'll add a property called UID. Set it to authentication.currentuser.uid. The current user property is an object that represents the current user who is logged into the application. If they're not logged in, this will be set to null. We don't have to worry about the object being empty because the user won't be able to visit this page if they're not logged in. It's safe to assume the user information is available. We can use this object to access the user's ID. The ID is unique. It was assigned to them when they registered an account. This will help us identify who uploaded the song. Afterward, we'll store the display name. Create a property called displayName. Set it to authentication.currentuser.displayName. We're storing the name because we want to display the name in the player when the user selects a song. The player isn't functional, but when we get to it, the name will come in handy. The next properties we'll want to store will be called original name and modified name. Set both of them to task.snapshot.ref.name. There are two things I want to note about this. Firstly, we're creating duplicate properties that store the same value. It's common practice to store the same value twice, depending on what the value will be used for. The application we're building allows the user to modify the name of the song after uploading it. If they update the name, then we'll have to make two requests to Firebase. One request to the database and another to the storage to rename the file. To cut those requests in half, we can have one property that will hold the original name and another property to hold the modified name. The modified name is what will be displayed on the front end. It'll be the property that will be modified if the user wishes to change the name. We won't have to rename the file in the storage. This is entirely optional, but it's a great way to cut down the amount of requests you'll have to make. The second thing I want to note is the value we're using for the two properties. The task object comes with a snapshot of the current upload. The snapshot object holds information about the current state of the upload. This object is the same snapshot object we're passed into the first function of the state changed event. The snapshot object will hold the reference to the upload. The reference represents the path to the file and its information. By using it, we can retrieve the name of the file. The next property we'll want to store is the genre. Set the genre property to an empty string. We'll leave the property empty. We can let the user set it later. In some cases, you'll be able to find the genre in the metadata of the file. If you insist on checking if the metadata exists for the genre, you can grab it with Firebase. In the resource section of this lecture, I provide a link to the file metadata documentation page. For this course, we won't be going that far. You can implement this yourself if it's something you'd like to do. Afterward, we'll add a property called comment count. Set it to 0. Users will be able to leave comments for songs. We'll want to keep track of how many comments were made to a song. This property will help us keep track of that. The last thing we'll want to store is the URL to the file. The song can't be played if we don't know where it's stored publicly. The URL to the file can be retrieved through the reference object. It comes with a function that will return a public URL to the file. Right after we create the object, add a new property called URL. Set it to task.snapshot.ref.getDownloadURL. This function will return a promise. We'll use async await to handle the promise. Add the async keyword to the function and the await keyword before the function call. It's time to submit the data to Firebase. Open the database in the Firebase console. We have a collection for users. We'll want to create another collection for songs. It's important we keep the user and song data separate from each other. This makes it easier to search through each collection individually if we ever need to. Click on Start Collection. The name of the collection will be called Songs. Firebase will ask us to create a document for the collection. We'll add some random information. Don't worry about what you input because we'll delete the document in a moment. After clicking Save, Firebase will create the collection and document. Click on the document inside the Songs collection. On the top right corner, we can delete the document. We'll be creating the document in the function. Back in the editor, open the Firebase configuration file. The first thing we'll do is create a collection object for the songs. We did something similar for the users collection. Below the users collection variable definition, define another variable called songs collection. Its value will be the object returned by the db.collection function. This function requires the name of the collection we'd like to select. Pass in songs. We're creating a variable because we want to be able to interact with the songs collection. We'll be dealing with the songs collection a couple of times in our application. It would be a good idea to create a reference for it where we can import it in our components. We'll add the songs collection variable to the export list. This export will allow us to use the collection in any of the components. Go back to the upload component file. We're going to import the collection we just created. Luckily, we're already importing the Firebase file. We can add on to the list of properties to import. The last step is to use the collection object to add the song. Scroll down to the function. After defining the song object, call the add function on the songs collection object. There are two functions for adding a document to a collection. The first is the set function. The function is what we use to add the user to the users collection. The second function is called add. The difference between the two is that the set function will allow you to assign a custom ID to the document. The add function will instruct Firebase to generate an ID for you. We're going to use the add function because we don't care about setting a custom ID for the document. It's quick and easy. This function has one argument, which is the object to add to the database. We'll pass in the song object. This function returns a promise. We'll add the await keyword before the function to wait for a response. We're not going to store the value returned because we aren't going to use it. We're finished. We'll want to test if this works. Before we do, go to the Firebase console and clear the storage. We want to start with a fresh slate. I've deleted the files in my app's storage ahead of time. Pause the video to do the same. Once you've got that taken care of, go ahead with uploading a file. After some time has passed, we will receive a success message. Go to the Firebase console to verify that the file was uploaded. It should still be placed inside the songs directory. Great, the song is still being stored in the storage. After verifying it's being stored, go to the database to confirm that the song information was inserted. Inside the songs collection, a new document was added. It was assigned a random ID. That's perfectly fine. We don't need a custom ID at this time. We're finished. We've created an elegant solution for uploading music. There are many ways we can improve the upload process, but I don't want to spend too much time as I've covered everything I wanted to cover. There is one thing I want to add. I want to create a fallback solution for users who aren't able to drag and drop files for one reason or another. We'll tackle this in an upcoming lecture. In this lecture, we're going to briefly discuss two terms that you'll hear often. I mentioned them a lot in the past few lectures. I'm talking about references and snapshots. I frequently get asked by students what the differences are because they seem similar. Let's talk about them independently. We are starting with references. A reference is an object that points to a location in your application. So far, we've learned we can create references to either the database or storage. By pointing to a location in the application, we can perform operations such as reading and writing to that location. We used references to upload a file to the storage and add data to the database. References can create other references. During the development of the uploader, we created a root reference. The root reference was used to create another reference to the location where the file will be uploaded. It's common practice to create a reference at the root location and another for a specific location. This allows you to create multiple references. Next, let's talk about snapshots. Snapshots are objects that are a copy of a location in your application. They're read-only and are immutable. Immutable means they can't be updated. If you were to attempt to update a snapshot, those changes wouldn't be reflected in Firebase. Whenever we make a change to the application, it's typical for Firebase to respond with a snapshot. One example of a snapshot was when we initiated the upload to Firebase. We were able to use the snapshot to gather information about the upload in progress. We were even able to grab the reference. Some snapshots come with a reference. In summary, references and snapshots allow you to read the data in Firebase. References can be used to manipulate the data in your application. However, snapshots are read-only objects. This makes them memory efficient. This is why Firebase has snapshots. You won't always want to interact with Firebase. Snapshots make your application more lightweight. As a result, this makes your application run faster. One last point I want to make is that snapshots are usually returned whenever you listen to changes using a reference. You can't create a snapshot directly. It's created for you during events. Hopefully, this makes things a little clearer when reading the documentation. You'll find both words thrown around a lot. Knowing the difference will make development easier. In this lecture, we're going to add fallback support for the uploader. Adding drag and drop capability looks cool, and it is. Despite that, we may want to consider adding a fallback because it is prone to errors. We did face a couple of issues when using it. In the resource section of this lecture, I provide a link to a site called Can I Use. I highly recommend bookmarking this site. You can look up which APIs can be used in which browsers. Most modern browsers support the drag and drop feature. It's not something that's supported on mobile devices. In these cases, going with the tried and true is what will yield the best experience for our users. That's done by adding a file upload input field. It works on all browsers and devices because it's been around for a long time. Implementing the file input won't take much work. We've written most of the logic for uploading a file. The difference will be dealing with how we retrieve the file. Let's get started. In the editor, open the Upload Component file. We'll want to add a file input field to the template. We're going to place it under the Upload drop box. File inputs can accept multiple uploads by adding the Multiple attribute. This is an HTML attribute. It's not related to Vue. The next thing we'll want to do is listen to the change event. During this event, call the upload function with the event object passed in. We'll need to update the upload function because the files are stored in another location if uploaded through a file input. Let's see where the list of files is stored. Inside the function, we're going to log the event object. Next, we'll proceed with uploading a file through the file input in the browser. An error will get produced in the console, but that's perfectly fine. We're interested in inspecting the contents of the event object. Inside the object, we have the same properties as before. One significant difference is that there isn't a data transfer object. This is not an error or a bug. The data transfer object is exposed if the event was triggered by a drag and drop event. This is why we get an error in the console. We can find the list of files under the target object. The target object refers to the input field element. It's what we attached the event listener to. The target will come with the files object. This object is the same object we looped through to upload the files. It becomes obvious what it is that we need to do. We'll need to make a small adjustment to our function. It should check if the data transfer property exists on the event. If it does, we'll use it. Otherwise, we'll grab the files from the target property. Back in the editor, we're going to remove the log statement. We don't need it anymore. The files variable will need to be updated. Instead of directly setting it to the data transfer object, we'll use a ternary operator. We'll want to create a conditional statement that will check if the event was triggered by a drag and drop or a change event. The condition will check if the events.dataTransfer object is present. This property gets defined if the event was a drag and drop event. It won't exist if it's a different event. If this condition turns out to be true, we'll want to set the files variable to the events.dataTransfer.files property. Otherwise, we'll set it to event.target.files. In both scenarios, we're still using the spread operator because the property will always be an object. This line will convert them into an array. We won't need to make any further modifications. The files property are the same in both events. We shouldn't experience further issues. Let's try testing the uploader one more time. The upload will ultimately be a success. Either upload will work in any order we please. The console shouldn't produce errors either. Creating a fallback is never a bad idea. You will always want to consider scenarios like this. In this lecture, we're going to learn how to cancel the upload. We've accomplished the task of uploading a file to Firebase. There is an issue with the process that can be easily overlooked if you don't examine the developer tools. Let me show you the problem. I'm currently on the Manage page with the developer tools opened. In the Network panel, I've filtered the results to show XHR requests. I'm going to upload a large file. Immediately after initiating the upload, I'm going to navigate to another part of the application. It doesn't matter which page. After navigating to another page, you'll notice that the request is still ongoing. Even the request to the database is made. Navigating back to the Manage page will show that the component has been reset. This is important to understand. When you navigate to another page, the component from the previous page will get unmounted. This applies to its children components too. We can prove this further by switching to the View Developer Tools Component tab. I'll search for the Upload component quickly. The Upload component will tell us that the Uploads array is empty. View will take care of cleaning up the data, methods, and computed properties after a component has been unmounted. The purpose of unmounting a component is to free memory on the user's machine. This will allow memory to be allocated elsewhere. View does its part with cleaning up the application. However, it doesn't clean everything for us. It won't take care of requests made by us. Simple requests won't tax the application, but a file upload can. Transferring large amounts of data can eat bandwidth and storage. If the user navigates away from the page, we'll want to stop the request. I'll be showing you two approaches to stopping the request. I'll go over their benefits after I've shown you both methods of handling this. The first approach is by using a lifecycle function. Two lifecycle functions are called when a component is unmounted. It's the perfect time to cancel the request if the user navigates away from the page. Open the Upload component in your editor. Define the BeforeUnmount lifecycle function. This function will run before the component is unmounted. We'll have access to the data, method, and computed properties stored in the component. We'll want to cancel the upload before the component is unmounted from the document. Inside the function, we'll want to loop through the objects in the uploads array. In each object, we pushed the task snapshot into it. The task will come with a method we can use to cancel the upload. We can only cancel each upload one at a time. We'll need to loop through the array to pull this off. We'll call the forEach method and pass in an arrow function. We're passed in each object through the parameters of the function. We're calling each item upload. We have the option of accepting the index and array, but we won't need them in this example. If you can recall, we added the task object to each object in the array. The task comes with a method that we can call to cancel the upload. In the loop, call the upload.task.cancel function. This function will cease upload operations to Firebase. We don't need to make further changes. That should take care of it. Let's try testing an upload again. Be sure to have the network panel opened in the developer tools. We want to verify that requests are getting canceled after we've navigated away from the page. Navigating away has canceled the upload. We can verify this by switching to the console panel in the developer tools. If an upload is canceled, the state changed event will throw an error. The second function we passed in will run. The second function we passed into the event is responsible for handling errors. Further inspection of this object will show that the cause of the error was cancellation by the user. Technically not an error because it's not something that breaks our application, but it's treated as such by Firebase. That's good to know just in case you want to handle the cancellation further in the function. We'll look at an alternative in the next lecture. In this lecture, we're going to look at another way of canceling uploads. The other approach is by using navigation guards. In the previous section, we extensively went over how navigation guards work and what they can be used for. I introduced 3 navigation guards for when a user is entering a new route. There's a fourth guard I didn't go over. You can run a guard for when a user leaves a route. The fourth guard can be defined inside the component. However, we face an issue. Navigation guards must be defined in the component that's registered to the router. The upload component is not the component we registered on the manage route. It's a child component of the manage component. Open the manage component file. Inside the exported object, define the function before route leave. Like all navigation cards, we can use the parameters to, from, and next. Here's where the issue arises. We don't have access to the data in the upload component. It is isolated even though we're using it as a child component. We can resolve this issue by using a feature called references. References are a way to select an element in the document. In JavaScript, there's already a method for selecting elements in the document. First, you would assign the element you'd like to select with an ID or class. Then, you would select it via the document object. The question is, why does Vue introduce a feature for selecting elements when vanilla JavaScript can do the trick? There are a few reasons for using references. The first reason is because they allow you to select components. Components can expose methods and properties to references. It opens the door for some interesting features and design patterns. You'll see an example in the next lecture. The second reason is because it makes it easier to select elements. Components are reusable. If you have an element with an ID, you may not be able to select that element if the component it's in is used multiple times. You can switch to classes, but what if you want to select an element in a specific instance of a component? You'd need to have a special ID assigned to the element. This can make things tricky. References were introduced to make selecting elements in your component easier. References are scoped to the component therein. For example, let's say you had a component being used twice in an app. Both components' references are independent from one another. You don't need to provide unique IDs every time. Vue will handle keeping them separate. Before we dive back into our project, I want to make one important point about references. They're not a frequently used feature in Vue. There are usually better alternative solutions. However, at the end of the day, references may just be the solution you're looking for when everything else doesn't work. Inside the template block of the manage component, we're going to attach the reference property to the app upload component. We'll call it upload. The ref attribute will create a reference to the element you're adding it to. The value of the attribute will be the name of the reference. Next, in the before route leave function, we can interact with the component by using the following: this.refs.upload. The refs object is an object defined by Vue. It's injected into every instance and component. It'll contain a list of references registered in your application. A reference can be registered by adding the ref attribute to an element in the template. Each object in the refs property represents the DOM element on the page. The object itself contains information about the element, such as its attributes and values. With references, we can call a method inside the component we're accessing. This isn't something that was ordinarily available before using references. We don't have a method we can call, so let's create one. Back over to the upload component, we're going to create a method called cancel uploads. We're going to use the same code we used in the before unmount lifecycle function. We'll copy it over like so. We don't want the before unmount function to get called. We're going to comment it out. Next, we'll go back to the manage component to call the cancel uploads method using the reference. Lastly, call the next function. The user won't be able to navigate away from the page if this function isn't called. It's an important step. We'll give the upload one last test. I'll upload a file and navigate away right afterward. The console will log the Firebase error again. It'll contain the same error code we saw before. The user has canceled the upload. Alright, let's discuss why you might choose one approach over the other. Both solutions are suitable. In our case, canceling uploads in the lifecycle function is the more appropriate way to handle things. It's less code, and we don't have to call it ourselves because Vue will call it for us. The second approach requires more code, but it may be the solution you're looking for. You may want to perform multiple tasks when a user leaves a route. Having components call their own lifecycle functions can become hard to manage. With navigation guards, you give yourself more control in the order of execution. It is a bit excessive in this example. However, I wanted to show you in case you run into a scenario where you will need to call a child's method. I'm going to comment out the before route leave navigation guard in the manage component. Next, I'll uncomment the before unmount lifecycle function in the upload component. This is the solution we'll be using for this course. There's one more thing I want to point out. It's important to keep an eye on your application with the developer tools. The console didn't catch this problem, nor did we see anything suspicious on the page itself. We were able to catch the problem after viewing the network panel. Just because an error isn't being produced doesn't mean that it isn't a problem. It's always a good idea to keep an eye on the requests being made to prevent the overuse of bandwidth. In this lecture, I want to quickly discuss one problem you may encounter with references. We saw how references could give us access to child component methods. They allow us to select elements in the document. We'll be able to read and write to the element completely. However, they're not a commonly used feature. They should be used as a last resort. Let's look at why that is the case. In the resource section of this lecture, I provide a zip file with everything you'll need. Unzip the contents and open the files in your editor. There's not much going on. We don't need anything else other than the Vue library to learn about references. You'll find two files in the project, one HTML and one JavaScript file. I've gone ahead with preparing most of the code for you. Let's review both files. In the HTML file, we're loading in the Vue library and app.js file. We have a div element containing the app we'll build. Inside the div element, we have an h1 tag. An expression called title is being outputted. Let's switch over to the app file. Nothing unusual is happening in this file. We're creating a variable called app that's being assigned to a new instance of the Vue object. Inside the instance, we have the data function. There's one property called title. Its initial value is set to hello. That wraps up the code review. The issue I'm referring to when using refs is that they're not reactive. If we make a change to an element through a reference, the Vue instance will not receive the change. Let's look at an example. In the template, we're going to add the ref attribute to the heading. We'll set it to greeting. The h1 tag will have the inner text, hello, since that's the value of the title property. Let's try changing the inner text via the reference. Below the Vue instance, I'm going to access the refs.greeting property. You're not limited to retrieving values with references. You're allowed to manipulate any of the object's properties, such as its inner text or attributes. I'm going to update the inner text property to the following: another hello. What do you think will happen? Will the browser render the expression or the update we made to the reference? Let's find out. Refresh the page on the browser. The text gets updated to the following: another hello. This is great because we have another way of changing the DOM with Vue. However, there is a huge flaw in this approach. The changes we made to the DOM via references are not reflected in the instance. We can verify this by opening the Vue developer tools. In the View panel, we can inspect the Vue instance. Under the data category, the title property is still set to hello. Even though we changed the element, we didn't change the instance. References can't change the Vue instance or its data. You only have access to the DOM itself. So what exactly is going on and why? Throughout this course, we've been changing the data in the Vue instance. This process can be done through a directive, an event, or with watchers. Anytime you change the data, you're updating the Vue instance. After updating the Vue instance, the changes will get reflected in the template. The changes then become rendered onto the DOM. This is how reactivity works. Any changes to the data result in changes to the DOM. Vue will take care of updating everything for you. However, with references, the story changes. A reference gives you direct access to the DOM. If you change the DOM through a reference, the Vue instance is not updated. Therefore, Vue will not keep track of any changes for you. This is why the data doesn't update. As we saw in our example, when we viewed the data with the Vue developer tools, the data didn't change. To summarize, references are a way to access the DOM elements in your application directly. Any changes made through references are not reactive. In most cases, you should be able to create applications without references. They're rare to use, but they could be the solution you're looking for when any other solution is not suitable. In this lecture, we're going to work on listing the files the user has uploaded. The first half of the page is complete. We've managed to provide upload capabilities for our application. The second half of the page will allow users to modify the songs they upload. I've provided a basic UI of what that would look like. The user's songs will be displayed as a list. They'll have two options. They can modify the file or delete it. If they choose to modify a file, a form will appear. The form can be used to change the name and genre of the song. You have the knowledge to tackle this on your own. If you wish to try it on your own, then go ahead. I will say that there are challenges you'll come across when trying to make the form functional. If you get stuck or don't feel completely confident doing it on your own, then that's fine. We'll be doing it together. I'll be sure to point out the issues we face when building the second part of this page. Before we write a single line of code, we should consider how we're going to approach this. We know that we're going to need the list of songs the user has uploaded. A request to the database will be necessary. We also know that we're going to have to loop through the data once we've obtained it. From there, we can make the buttons interactive. Lastly, we'll need to make the form functional by submitting the changes to the database. Alright, now that we have a general outline of things, let's get started. The first step is to retrieve the data from Firebase. We want to retrieve the list of songs the user has uploaded so far. The data should be requested before the component gets loaded on the page. It would make sense to use a lifecycle function. In the editor, we'll be working in the Manage component file. Down in the script block, we'll add the created lifecycle function to the exported object. The created lifecycle function is the earliest moment we can request the data. We're going to make the function asynchronous by adding the async keyword. There's one important thing I want to point out about asynchronous lifecycle functions. Vue will not wait for the code inside to be executed if you're writing an asynchronous function. This will mean that the component will load the template onto the page even if we have an asynchronous lifecycle function. It's not a big deal for us. We'll proceed with making the request. Firebase will need to be imported into the component if we want to make a request to the database. At the top of the file, import the Firebase file for the songs collection object and authentication service. We're importing the songs collection object because we want to retrieve the list of songs from the database. This object will allow us to interact with the collection in the database directly. The authentication service will let us retrieve the ID of the user. If you can recall, we stored the ID of the user with the song data. This will help identify the user who uploaded the song. We want to make sure we're filtering the songs retrieved to the songs uploaded by the user. This is why we're importing the authentication service. The next step is to begin requesting the data. Back in the created function, we're going to perform a query. The word query means to request data from a database. We want to query the database for the songs. Querying can be done by calling the where function on the songs collection object. The songs collection object comes with functions for retrieving documents from inside it. We don't want to grab every document in the collection. The where function helps us with filtering through the documents. At the end of the day, documents are objects. We can create a condition to check if a property matches a value. We can pass in 3 arguments for creating the condition. We're going to create a condition for checking if the user ID in the document matches the ID of the user logged in. The first argument is the name of the property it should check in the document. Pass in UID. This property is where we're storing the ID of the user in the document. The next argument is the comparison operator. Pass in equals equals. Lastly, we need to pass in the value to compare to. We've already imported the authentication service. We can use the current user object to access the UID property. This function will generate a query instructing Firebase to search through the documents in the songs collection. It'll check if the UID property is equal to the ID of the user currently logged in. If there's a match, it'll return the document. This function is an asynchronous task. We'll need to add the await keyword before the function. The last thing we'll need to do is initiate the query. The where function doesn't begin searching through the collection. It merely creates the query for searching through the documents. We can initiate the query by chaining the get function. This function will return the documents it finds. We'll want to save the data from the response. The get function will return a snapshot. Assign the documents returned by the function to a variable called snapshot. We're finished with querying the database. We have the song data returned by the database. The next step is to display the results to the user. We'll handle this situation in the next lecture. In this lecture, we're going to render the list of songs to the user. The first thing we'll do is store the snapshot data in the component. We have the option of storing it in the state, but we're not going to do that because the data doesn't need to be globally available. The purpose of this page is for the user to manage the music they've uploaded. They'll have permission to modify or remove the music they've uploaded. There's no reason for this kind of data to be available on every page. If the user is on a page where they can't edit their data, there isn't a reason for that data to be present. It takes up room and space on the machine. You want to be as efficient as possible when developing your applications. It's important to reduce overhead whenever possible. Inside the component, define the data function. We'll create a property called songs. Its value will be an empty array. We'll want to push the documents into the songs array. We have the option of storing the snapshot, but we're not going to do that. The snapshot has additional properties and methods we don't need. It would be best if we were to store the minimum amount of information for efficiency. In the created function, we're going to loop through the snapshot array with the forEach function. We can pass in an arrow function to handle each iteration. The arrow function will have one parameter called document. We'll store the document, but only its data. Create a variable called song. We'll set it to an object. Inside the object, call the function document.data with the spread operator. The data function will return the data inside the document. We're not interested in the other properties in the document object. The spread operator will merge the properties with the song variable. There is one problem with this. The data function will not return the ID of the document. We'll need the ID if we want the user to update the document. Create another property called documentID. Set it to document.id. It's important we store the ID because we'll allow the user to edit the song in a future lecture. The ID will make sure we update the correct document when the user submits their changes. We've created a stripped down version of the document. It's the ID with the contents of the data. Any other additional properties won't be pushed to the array. The last thing we'll do is push the song object into the songs array with the push method. Let's give things a test. In the browser, refresh the page. Nothing will change because we aren't presenting the data yet. We'll get to that in a moment. First, let's use the developer tools to check the component data. Under the Components tab, search for the Manage component. Listed under the Data category, we'll find the Songs array filled with the songs from Firebase. We've successfully retrieved and stored the song data. Before we move on to the next step, let's test if filtering works. At the moment, we're being returned all the songs because we're the only ones that have been uploading music. We aren't entirely sure if the filtering works. We can test the filtering by modifying one of the songs in the database. You don't have to do this, but I want to show you that we're receiving filtered results. Switch to the Firebase console. In the database, I'll view one of these song documents. I'm going to modify the UID property slightly. After making that change, I'll refresh the page. The request will still work. This time, if I were to view the list of songs returned, the song that was modified won't appear in the list. This is because the user ID doesn't match the ID stored in the application. This proves that the filtering worked. I'm going to undo the change I made to the database. In the next lecture, we're going to begin rendering the list of songs. In this lecture, we're going to render the list of songs. We want to output them to the user. We've verified that everything is being set properly. Before we start looping through the array of songs, we should outsource the template into a separate component. This is to reduce clutter from within the Manage component. In the Components directory, create a file called compositionitem.view. The component will need some template and script blocks. We can scaffold those by typing view. The style block will be unnecessary. The next thing we will do is move the template. Back in the Manage component, search for the comment that says Composition Item. There are 5 div tags below this comment. They're dummy list items. We don't need them anymore. Remove the composition item elements except for the first one. We'll use this as the base template. Cut this from the template and move it over to the composition item component. While we're here, let's add a name to the component. We'll set the name option to composition item. The component is ready. It needs to be registered with the Manage component if we want to load it. Back in the Manage component, we're going to add an import statement for the composition item component. The path to the component is @/components/compositionitem.view. Next, in the Components option, we'll add the composition item component to the list of components. We can start displaying the songs. In the template block, we're going to load the composition item component where we previously cut the element. We're going to add it under the comment that says composition item. The job of the composition item component is to display a single song. We're going to loop over this component. Apply the v-for directive to the single composition item component. The expression will be song in songs. Afterward, we'll bind the key property to the song.documentID property. We'll leave it at that for now. Let's view the browser to check if the list items are rendering correctly. The array of songs have been looped through. We will see the form multiple times. It should be hidden, but we'll get to that in another lecture. The main focus of this lecture was to display the list of songs from Firebase. In the next lecture, we'll begin passing on the song data to the component. In this lecture, we are going to learn about prompt validation. We have a component called composition item. it's going to need some data for it to function properly. Without data, it'll produce an error. As developers, we want errors that are descriptive. We can tell Vue that a component requires a specific prop by validating the prop. We may accidentally end up passing in a wrong prop or forget to add a prop to a component. Prop validation can help us by enforcing some rules on a prop. Let's explore how prop validation works. The component item needs the song data from the parent component. In the components option, we will add the props option. Previously, we would set this option to an array. The array would be a list of properties the component can accept. There's an alternative value we can set this option to. We can set it to an object. In this object, we can configure props rather than setting their name. We're going to add one prop called song. In this object, there are a few settings we can add. The first setting we're going to add is called type. The type option allows to constrain the data type of the prop. We can restrict the data type to a string, number, boolean, etc. From what we know, each item in the array is an object. We'll set this option to object. The next option we're going to add is called required. This option allows us to configure if the prop is required or not. The component will throw an error if the prop is undefined. By default, it's set to false. We'll change this option to true. We've successfully validated the prop. With these options, we can make sure the parent component is passing on the correct prop. If we forget to add a prop, we will receive an error telling us the problem. Let's try testing the program. Refresh the page in the browser. The Manage page isn't working anymore. In the console, we'll receive an error telling us that the song prop is missing. This information is incredibly helpful because we know where the problem is. Back in the editor, open the Manage component. On the composition item component, we will bind the song prop to the song reference. Next, let's check the page again. The list of songs is working again. Great! Thanks to prop validation, we will always know what a child component needs. In the next lecture, we will finish this component by toggling the form. In this lecture, we're going to toggle the form for editing a song. In our UI, we have a form for editing a song. This form should be hidden from the user unless they choose to edit a song. Next to each name, there's a button for editing a song. If this button is clicked, we will show the form. Let's get started. We will continue working in the composition item component. It's where the form is located. The first step we'll take is storing a property for toggling in the form. In the data object, we're going to create a property called showForm. Its initial value will be false. The next step is to update the template to use the data. In our components template, there's a button we can use to toggle the property. The forms shouldn't appear until the user clicks on the edit button. First, we'll hide the form based on the property. There are div tags in the composition item element. The first div tag surrounds the name of the song. The second div tag surrounds the form. On the first div tag, we will add the vShow directive. The expression will check if the showForm property is false. Next, on the second div tag, we will add another vShow directive. The expression will check if the showForm property is true. We are toggling the name and form by using conditional directives. By default, the name will always appear. The last thing we'll do is provide a way to toggle between both elements. In the first div tag, there are two buttons. The first button is for deleting a song. The second button is for editing a song. On the second button, attach the click event listener with the prevent modifier. Inside the event, we'll want to set the showForm value to its opposite value. The following expression will work. showForm equals ! showForm. Before we test this, let's update the name. Inside the H4 tags, replace the static text with the expression song.modifiedName. That'll help us better distinguish each item on the list. Let's give things a test. Refresh the page in the browser. All forms are hidden from view. If we were to click on the Edit button, the form will toggle into view. We can move on to the next step, which is to make the form functional for editing the song. We'll take care of that in the next lecture. In this lecture, we're going to handle submitting the form for editing the song. You can find the form in the template block. There are two input fields for the title and genre. The goal is to bind both inputs to their respective data, add validation, and submit the form data to Firebase. You've learned how to accomplish these tasks throughout this course. This will be a great opportunity to try this out yourself. You have the knowledge to tackle this feature. Try making this form functional on your own. Pause the video and good luck. Welcome back. If you were able to solve this, that's great. If not, that's fine as well. We'll tackle it together. The first thing we'll do is validate the form. We want to prevent users from submitting the form if the inputs are valid. It's typically the first step we should take when working on forms. In the template, search for the form element. It'll be inside the second div tag. We're going to replace this element with the vForm component. The vForm component will validate the fields placed inside it. It'll generate a form element when we view the page. If we look inside the form, there are two fields, one for the title and another for the genre. We are going to add rules for both inputs. We can add the rules directly to the inputs. Alternatively, we can add a validation schema. A validation schema is an object of rules that will apply to our inputs. It'll make our code look a whole lot cleaner. We're going to go with a validation schema. Scroll down to the data function. We will add a new property called schema. Its value will be an object. The property name will refer to the name of the input field. The values for the properties will be the list of rules to apply to the input field. Let's add one property called modified name. The rules will apply to the title will be the required rule. The modified name property is where we are storing the name of the file. There are two properties for storing the name, one for the original, another that can be freely modified. Next, we'll add another property called genre. We'll apply the alpha spaces rule to this input. The genre input will be completely optional. If a user decides to provide a value, we will restrict the characters to alphabetic and space characters. Genres typically don't have numbers or strange characters in them. vValidate knows our rules. The next step is to tell it about our inputs and their rules. Back in the template, add a property called validation schema to the vForm component. We will bind this property to the schema data property. Next, we need to tell vValidate which inputs it should validate. The first input in our form is for the song title. We are going to convert this input from an input element to the vField component. This component will generate a field that will have validation performed on it. The attributes can stay on the component since they'll be passed on to the element it generates. We're going to add one property called name. The value for the name property must correspond to the property name we have in our schema object. We're going to set this property to the modified name property in our schema. We're going to do the same to the second field. Convert it from an input element to the vField component. Next, we'll add the name property. It'll be tied to the genre property in the scheme. Our fields will be validated, but the user won't know what's wrong with their field unless we output some errors. Feedback will help the user remedy the error. Let's handle the errors next. We'll start with the first field. Under the field component, add the error message component. We'll set the class attribute to TextRed600. This class will change the text color to red. Next, we'll set the name property to modified name. If we want to grab an error for a specific field, we can retrieve the errors by its name. The name of the property must match the name we assigned the field in the name property. If there isn't an error, the error will not appear. The markup and expression will be the same for the second input. Since that's the case, we'll copy the error message component entirely. Then, we'll paste it under the second input for the genre. We'll modify the name attribute to genre. We have completed validating the inputs. There are two more things we should do before we move on to the next step. Firstly, we should add some initial values to the fields. Currently, each field will be empty. We will want to pre-fill them with their respective song data. On the vForm component, we can pre-fill our fields by adding the initial values property. We are going to bind this property to the song prop. The second thing we're going to do is listen for the submit event. vValidate will make sure the inputs are valid before firing the submit event. We can safely listen for the submit event on the vForm component. The name of the function we will want to run will be called edit. This method doesn't exist in our component. Let's define it. In the component options, we will add the methods object. Inside this object, we will add the edit method. In this function, we will log a message to verify it was called. Let's test our form. In the browser, try submitting the form with invalid values. We will receive errors from the validator. That's the behavior we were looking for. Let's attempt to input some valid values and submit the form. In the console, we will find our message. We've successfully validated the form. The next step is to process the data. We will handle the form submission in the next lecture. In this lecture, we are going to handle the form submission for the song. The form we've created will update a specific song uploaded by a user. We're going to do what we did last time. We'll inform the user the status of their submission by using alerts. We are going to add additional data properties to the composition item component to manage the alerts. It's going to be similar to what we did with the login and registration forms. Let's get started. In our data function, we are going to add our properties. The first two will be called inSubmission and showAlert. Set both to false. The inSubmission property will be used to disable the submission button. By default, it'll be false to enable it. The showAlert property will be used to display the alert message. It'll also be false to hide the alert message. We'll create another property for the color of the alert box. Call it Alert Variant. Set it to BGBlue 500. This value will give us a blue alert box. Lastly, add a property called Alert Message. The value for it will be the following. Please wait, updating song info. We'll use this property for the inner text of the alert box. It's time to start adding the alert box to the template. Scroll up to the vForm component. Above this component, we will add the alert box. We'll add a div tag with the following classes: text white, text center, font bold, P4, MB4. We're going to add some properties to the element to make it dynamic. On the component, we'll add the VF directive with the expression showAlert. Then we'll bind the property to alert variant. In between the tags, add the expression alert message. One last thing. There are two buttons on the bottom of the form. One button will allow the user to submit the form. The other will allow them to go back. We are going to disable both buttons by binding the disabled attribute to the InSubmission property. If the user clicks on the second button, we should toggle out the form. We are going to add the Click Event Listener. In this listener, we will set the Show Form data property to false. This change will hide the form. Let's go back to our edit function. The edit function will need to do two things. Firstly, it should update the properties for the alert box and form. We should inform the user their submission has started. Secondly, it should send the data to Firebase. We will start with the alert box. The first properties we'll update are the InSubmission and Show Alert properties. Set both to true. This will disable the button and make the alert box visible. Afterward, the Alert Variant property will be set to BGBlue 500. It's already set to the BGBlue 500 class by default, but we want to make sure to reset it if the user resubmits the form. The message will also be the same as the default. The alert box is ready. We can start to make a request to the database. The type of request we'll want to make is to update the data. We've learned how to insert and select data in Firebase. Updating data won't be too different than what we've done before. A document can be updated after we've selected it. By selecting a document, Firebase will know which document we will want to update. At the top of the script block, we are going to import the Songs Collection object from our configuration file. We will need it if we want to be able to interact with the Songs collection. Back in the Edit function, after updating the alert properties, call the Songs Collection.Document function. The Document function allows you to select a document by its ID. We'll pass in the ID. The ID is stored in a property called Document ID. We stored the ID when we were querying the database. The Document function will return an object where we can access its data. In addition, we have access to functions for interacting with the document. We're going to chain a function called update. The update function will allow us to update any of the properties inside it. We're not required to update every property. If we omit a property, Firebase will leave the original value alone. We don't have to pass in the whole object. Another option is to add additional properties to the object. It's a flexible function. There are two properties we'll want to update. They're the modified name and genre properties. The question is, where do we get the current values from the form? vValidate will pass on the field value as an argument to our edit function. It's passed on for us automatically. We can accept the argument by adding the values parameter to the edit function. This object will contain the values from the fields. The values can be found under their respective names we assigned to the fields with the name property. The names already match the document's properties. We can pass this parameter onto the update function. The update function will return a promise. To run asynchronous tasks, the function should support async await. Add the async await keywords to their respective locations. It's possible for this function to throw an error. We'll want to handle that next. Surround the update function with a try-catch block statement. If we get an error, we'll do two things. First, we'll stop the function from running. Second, we'll update the alert properties to inform the user an error has occurred. The InSubmission property will be set to false. This will re-enable the form. Update the variant to BGRED 500. The message will be the following: something went wrong. Try again later. Lastly, we'll return the function. If the update function runs successfully, we'll update the alert properties to inform the user. We won't bother with redirecting or reloading the page. We'll even enable the form again if they want to make further changes. Like before, we'll set the InSubmission property to false. The variant will be set to BG500. Lastly, the message will be the following: Success. The process is pretty straightforward. Keep in mind, this is one way of tackling form submissions. You may want to do it another way. That's fine. This is just how I tackle form submissions. Let's give things a test. In the browser, edit any of the songs. After making changes to a song, we will be able to submit the form without them conflicting with one another. The form submission will work successfully, or so it seems. If we go back, the changes are not reflected. The reason we don't see the changes get reflected is because the data in the Manage component doesn't get updated. We'll need to send the changes up to the Manage component to apply the changes. Switch back to the editor. We'll fix this problem by defining a function inside the Manage component. This function will update the data in the Manage component. We'll pass it down to the Composition Item component. The Composition Item component will be able to call this function with the changes that need to be made. In the Manage component, we're going to define a function called UpdateSong in the Methods object. It'll have two parameters called I and values. The I parameter will be the index of the object to update. The Manage component won't know which song to update. It'll be up to the Composition Item component to provide the index of the song to update. The Values parameter will be the form data with the name and genre of the song. Inside this function, we'll update this.songs I.modifiedName property to the values.modifiedName property. Next, we'll update the this.songs I.genre property to the values.genre property. Our function is ready. Let's pass it down to the upload component. In the template, search for the Composition Item component. We're going to bind a property called UpdateSong to the component. While we're here, we should provide the index to the component. Strangely, the Composition Item component doesn't know its own index. If it has to provide the index to the Manage component, it'll need to know the index. First, we're going to update the v-for directive to grab the index. The alias for the index will be called I. Next, we'll bind a property called index to the index alias. Switch over to the Composition Item component. Scroll to the Props option. We should validate the function. We'll add the UpdateSong prop to the list. The type option will be set to function since we're expecting a function. The required option will be set to true. We'll do the same for the index prop. For the index prop, we'll set the type to number. Lastly, we'll set the required prop to true. The component is not functional if it can't update the song. We have everything we need. The last step is to the UpdateSong function. Scroll down to the bottom of the Edit function. We're going to call this function with the index and values props. Let's try testing the form. In the browser, edit any of the songs. If we switch back, the changes are reflected in the list. Great. Most of the songs will have the MP3 extension added to it. I'm going to remove them from each of the songs I've uploaded. I'll receive a success message from each form submission. Refreshing the page will show that each update persisted in the database. You can check the database if you would like further confirmation. I know I flew right by this. It was a lot of code to hook up the form. If you were confused with any part of the process, I recommend reviewing the last 3 sections. A lot of what we did was broken down in those lectures. The newest thing we learned was how to select an individual document from the collection by using the document function. Firebase will return an object with properties and methods for interacting with the document. We took advantage of one of the functions for updating the properties in a document. It isn't important to update every property. Firebase is flexible in this regard. In the next lecture, we will wrap things up with the Manage page. In this lecture, we're going to learn how to delete a song from the Firebase application. On the Manage page, every song item has a button for deleting a song. The button, if clicked, should initiate the process of deleting a song. We should carefully consider what to remove from Firebase. There are 2 locations in Firebase where we will want to remove the song: the file in the storage and the document in the database. After we've removed the file from both locations, we'll remove the song from the page. This will let the user know the song was successfully deleted. The first step is to listen to the click event on the button. Open the composition item component file. There are 2 sets of div tags inside this component. The inner contents of the first div tag have 2 buttons. The first button is for deleting the song. On this button, listen for the click event with the prevent modifier. We'll want to execute a function after it's been clicked. The name of the function will be called delete song. Next, let's define the function inside the methods object. I've made the function asynchronous because we'll be making requests to Firebase. Requests are typically asynchronous. In the function, we can start by deleting either the song in the storage or database. It doesn't really matter in this case. We'll start with the storage. A reference will need to be created if we want to interact with a file in the storage. For best practice, we'll create 2 references. One reference for the root of the storage and another for the specific file in the storage. The storage object needs to be imported if we want to create references. At the top of the script block, update the import statement for the Firebase object to include the storage object. Back in the function, create a variable called storageReference. Set it to storage.ref. Then, we'll make a reference to the song. Create a variable called songReference. Set it to storageReference.child. The child method will create a reference relative to the reference it's called on. It has one argument, which is the path relative to the reference it's being called on. This is the same thing we did when creating the song. Pass in the following: songs / this.song.original name. We stored the file with its original name. It's important that we're using the original name property. We don't want to use the modified name property because the user can freely change it. If we were to use the modified name property, we may receive an error, or even worse, an incorrect file may get deleted. References come with a method called delete. As its name suggests, this will delete the file from the storage. We'll call it after defining the song reference. It's an asynchronous task. We'll add the await keyword before it. This function will delete the MP3 file from the storage. In the resource section of this lecture, I provide a link to the Delete Files documentation page. Deleting a file is pretty straightforward. Firebase doesn't give many details besides showing you how to perform a deletion. The delete method returns a promise for handling their response. There is one thing that isn't properly documented. The rules need to be adjusted to allow users to delete their files. The code we have won't work because we haven't written the rules for deleting a file. In the resource section of this lecture, I provide a link to the Storage Security Rules documentation page. There's a section called Granular Options. This section will tell you that you can create rules for different actions. They don't have to be so broad. You're not stuck to using the read and write rules. Currently, the rules we have will reject the request to delete the file. To better understand, let's examine the rules we have in the storage. In the Firebase console, navigate to the rules for the storage. The write rule has three conditions. We're checking for authentication, size, and MIME type. If none of them pass, the user will be rejected from writing to the storage. Deletion is considered a part of the writing process. So any files that get deleted will need to pass these rules. We'll never be able to delete a file because we're not sending a file. The request.resource property we're using in the rules will be empty. Therefore, the size and content type properties will be blank. The request will be rejected because both rules can't pass. We can resolve this by defining the delete rule. After the write rule, we can add the delete rule by adding the following: allow delete. The condition we'll want to perform will be the same as the first condition for the allow write rule. We're lowering the requirements for deleting a file. The only thing we want to check for is if the user is authenticated. If they are, we'll let them delete the file. That should take care of deleting the file from the storage. Publish the changes for them to take effect. The next thing we'll do is delete the data from the collection. Go back to the editor. In the function, we're going to need to select the document for interacting with it. We'll use the songs collection function to select the document with the document function. This function will need the ID of the document. We can access the ID by using the following: this.song.documentID. This is the same thing we did in the update function. The main difference will be the action that precedes this method. We can delete a document by calling the delete function. This function will return a promise. We'll want to add the await keyword before calling the function to wait for the request to be completed. There's one last thing we'll do in the function. The song will still appear on the list because it's in the uploads array. It will need to be removed. This is where things will get tricky. We are in a child component. We don't have access to the array. We only have access to a single song. Luckily, we have an idea for how we can delete the song from the child component. We can solve this issue by creating a function in the manage component. The function will be passed onto the composition item component for deleting a song. Switch over to the manage component. Search for the composition item component in the loop. We are going to send a function to the composition item component. We will bind a property to the component called removeSong. Its value will be a method called removeSong. This method doesn't exist in our manage component. We will define it in the methods object next. The job of this method is to remove the song from the array. We can accomplish this with regular array methods. First, we need to know the index. The component will provide us with the index. We'll add it as an argument to the method. Inside the function, we will add the following: this.songs.splice I1. The splice function will remove items from an array. We are using it to remove the song. The last thing we need to do is call this function from within the composition item component. Switch over to it. We are going to modify the props. We're going to add the removeSong prop. The type for this prop will be function. It'll be a required prop. We can finally invoke this function. Back in our deleteSong method, we will call the this.removeSong function where we will pass on the index prop. Let's give things a test. Refresh the Manage page in your browser. Next, click on the Delete button for any of the songs. After a few moments, the song will disappear from the list. In the Chrome Developer Tools, we won't receive errors in the console or network panels. This is great. The requests seem to work fine, especially the request for deleting the file from the storage. By updating the rules, Firebase allowed the file to be deleted from the storage. Let's verify things in the Firebase console. Go to the database. Under the Songs collection, the song we deleted shouldn't be there. Next, check the storage for the file. It has been removed from there too. That's great. We've successfully deleted a song from the database, storage, and page. We can wrap things up in the next lecture. We're almost finished. In this lecture, we're going to look at an issue that can be easily overlooked. To demonstrate, I'm going to upload a song. After a while, the song is successfully uploaded to Firebase. Even though we're receiving a success message, it doesn't appear on the list. The list does not get updated with the latest uploads. This is a problem. We want the user to be able to edit their songs after they have uploaded them. If I were to refresh the page, the song is added to the list. This is not a problem with Firebase. We need to push the song into the list. That'll be easy to do, but there is one challenge we will need to overcome. Open the Manage and Upload component files in your editor. The Upload component is a child of the Manage component. The Songs array is defined in the Manage component. We need to push the song from the Upload component to the Manage component. This can be done in a variety of ways. The approach we'll take is by using component properties. We'll pass a function from the Manage component to the Upload component. If the upload was a success, we'll call the function. The function will have access to the data properties and methods in the Manage component because it's defined in the parent component. We'll be able to push the song into the array. It's a quick and easy solution. Let's look at how it's done. First, we'll define the function for adding a song. This function needs to be defined in the Manage component. Otherwise, we won't be able to push the song into the Songs array. Inside the Methods object, define a function called addSong. This is a function we'll pass to the Upload component. We can do that by using component properties. Scroll to the template block and search for the App Upload component. A component property can be added by adding a custom property to the component. We're going to create a component property for the addSong function. We'll call the property addSong. You don't have to call it the same name as the function. You can assign it any name you'd like. If we want to set this to the addSong function, we'll need to bind this property to the addSong function. View will pass down the function to the child component if it accepts the property. We'll need to handle that next. Switch to the Upload component file. In the exported object, we can accept the property by adding the props property. This property will be set to an array of properties we can accept. The names must be passed in as a string. We're going to accept the property that was passed down by the parent component. It's called addSong. The addSong function will be accessible via the this keyword. We'll want to call the function when the upload is a success. The logic for the upload is written in the upload function. Towards the end of the function, there's a request made to the song collection. I'm referring to the add function. This function will return a document reference. We'll want to pass the document reference to the Manage component. First, we need to assign the reference to a variable. We'll call it songRef. This variable can be passed to the component with the function we created. Call the addSong function with the songRef variable. By passing the document reference, we'll be able to push its data into the Songs array in the Manage component. The last thing we'll need to do is handle the logic. Go back to the component. In the add song function, we'll want to create the application data, merge it with the song data, and then push the merged data into the array. We did this already in the created function. We can save ourselves the time of having to rewrite the logic by refactoring the code. We'll move the logic from the created function to the add song function. Up in the created function, cut everything inside the loop. Next, paste it into the add song function. This function will break the page for a moment because we're not pushing anything inside the created function. Go back to where we cut the previous code. Instead of passing in an arrow function, we'll replace it entirely with the add song function. Let's try testing this out. Go back to the browser and refresh the page. The list will render without a problem. We outsourced the code for pushing the songs into the array in a separate function. Let's try uploading a file to see if the song gets pushed. Nothing happens. Why is that? Let's check the developer tools to see what's going on. In the console panel, we'll receive an error. It's stating that the data function is undefined. This is because we're treating a reference as if it were a snapshot. We discussed the differences between references and snapshots. References are objects that provide properties and methods for interacting with the document. Snapshots are read-only objects of the data in the document. To better understand, let's go back to the editor. In the created function, we're calling two functions, where and get. The result of this will be an array of document snapshots. We're looping through the array to pass the document snapshot to the add song function. Down in the add song function, it's expecting the object to be a snapshot. Snapshots come with a method called data. This is why the code works as expected. Switch to the upload component file. Right before we call the add song function, we're storing the document in a variable called song reference. The add function returns a reference, not a snapshot. This reference comes with different methods and properties than a snapshot. There is no data function on the reference. This is why we're getting an error. The add song function is expecting a snapshot, not a reference. So the question becomes, how do we get a snapshot of the song we uploaded? We can use references to create snapshots by calling the get function. After the song reference variable, we'll create another variable called song snapshot. It'll be set to the song reference.get function. This will return a promise. We'll add the await keyword before it. The argument we're passing to the add song function will need to be updated. Replace the song reference variable with the song snapshot variable. If we did everything right, the upload should appear in the list. Save your changes. In the browser, refresh the page and attempt to upload a file. After a few moments, the green checkmark will appear. This checkmark tells us the upload was a success. The song appears on the list as we wanted. We've successfully taken care of the issue. The user will be able to edit their songs after uploading them. In the next lecture, we will finalize the Manage page with one more feature. In this lecture, we are going to add a feature that will enhance the user experience. Tell me if this has ever happened to you. You're filling out a form, and suddenly, you accidentally hit the back button, or you swiped in the wrong direction. Your device may register this as wanting to navigate away from the page. When you come back to the form, it's entirely empty. You will have to fill it out again. This type of accident is more common than you think. It's a very annoying thing to experience. There are a lot of apps that are fixing this by asking the user if they're sure about navigating to a different page. We can implement a similar feature with navigation guards. Navigation guards allow us to perform an action before the user navigates to the next page. There's a navigation guard we can add to our components that will be fired before a user navigates away to another page. We will use this navigation guard to ask the user if they're sure about their action. We will be working in the Manage component file. Open it in your editor. In the Components Configuration options, define a method called BeforeRouteLeave. The BeforeRouteLeave navigation guard runs whenever the router is moving away from the current component. This gives us the opportunity to stop the router from leaving the page if the user is filling out a form. It can accept the usual parameters to, from, and next. The first thing we need to do is detect if a user is filling out a form. There isn't a point in stopping the user from navigating away from the page if they haven't made changes to their songs. We will create a data property for keeping track of any edits to the songs. In the data object, add a property called unsavedFlag. Its value will be false. It's going to hold a Boolean value. If it's true, we should attempt to stop the user from navigating away. This property should be updated whenever the values change in any of the songs. The data property is stored in the Manage component, but the fields are in the Composition item component. We're going to do what we did last time. We will create a function for modifying the value in the Manage component. This function will be passed down to the Composition item component. It'll be able to call this function whenever the inputs change. Let's define the method. In the Manage Components options, we will define a method called updateUnsavedFlag. This method will have one parameter called value. The value parameter will be used for the unsavedFlag property. In the function, we are going to set the unsavedFlag data property to the value argument. Our function is ready. Let's pass it on to the Composition item component. Above, in the template, we are going to bind a property called updateUnsavedFlag. We will bind this to the updateUnsavedFlag method. The Composition item component will need to accept the function as a prop. We will switch over to this component. Scroll down to the props object we created earlier. We will add onto the object by adding the updateUnsavedFlag prop. The type option will be configured to function. We're not going to add the required prop because it won't be necessary for this function to be available. We will make it optional. The next step is to call this function whenever the fields are updated. In the template, we have two fields. They both should call this function whenever they're updated. We can add the input event listener to the vField components. After all, the field component will generate an input. The properties we add to this component will be passed on to the element it generates. We can add event listeners to detect changes to the field. We'll start with the text field for the song title. We will add an input event listener to the field component. We will run the updateUnsavedChanges function. This function expects a value. We will pass in true. This event listener will be the same for the genre field. We will copy and paste it over to the other field component. The input event is fired whenever the value for the field changes. This will let us become aware of unsaved changes. But what if the user saves their changes? We should turn the flag off. In our Composition item component, we have a function that will handle the form submission called edit. At the end of this function, after we've confirmed the submission was a success, we will call the updateUnsavedChanges again. This time we will pass in false to turn the flag off. We've created a flag for storing the status of the user's edits. If it's true, they have unsaved changes. We should prevent them from navigating away from the page. Let's handle that next. Back in the Manage component, we are going to update the BeforeRouteLeave function. We will add a conditional statement that will check if the this.unsaved flag is false. If it's false, we'll know there aren't unsaved changes. We can proceed to let the user navigate to the next page. We don't always want to prevent them from navigating away if there isn't a reason to hold them on the same page. Inside this conditional block, we will call the next function. The next function will allow the router to proceed. If the user has unsaved changes, we should ask them if they're sure about leaving. After the conditional statement, we will add an else block. Inside this block, we will create a variable called leave. Its value will be the confirm function. The confirm function will produce a prompt. The user will be given two options to proceed with their action or cancel their action. It'll return a Boolean value we can store in a variable. We can customize the message in the prompt by passing in a string. Our prompt will say the following: "You have unsaved changes. Are you sure you want to leave?" ESLint may throw an error because the confirm function is considered an alert function. The rules we have installed disallow this function. However, we will need it for this one scenario. We don't want to disable a rule on a global level. Luckily, ESLint can be disabled for specific lines. If I hover my mouse over the confirm function, we will be shown the rules that are broken. We can select the quick fix option to disable these rules for this line. We are going to select the disable option for the no alert rule. A comment will appear above the line. This won't do anything to our program. ESLint will detect this line and avoid applying the no alert rule to the line. In addition, there's another rule that will be broken called no restricted globals. This rule enforces that we shouldn't use global variables. The confirm function is a global function defined by the browser. We will want to disable this rule too. We can add it by adding a comma followed by the name of the rule. I don't always recommend disabling rules. We should always adhere to a standard. For this situation, it's perfectly fine. The confirm function will return a Boolean value. We are going to pass this value onto the next function. The next function has one optional argument. We can pass in a Boolean value to tell the router whether to proceed with the navigation. If we pass in false, it's the same as not calling the function. A true Boolean value will tell the router to move on to the next page. Let's try testing our new feature. In the browser, refresh the Manage page. If I browse to another route, nothing happens. That's the behavior we want originally. This time around, I will edit a field without saving it. If I were to navigate to a different page, I will be prompted about my attempt. It'll ask if I'm sure about navigating away from the page with unsaved changes. If I click Cancel, I will remain on the page. We're officially finished with the Manage page. The user is able to upload, edit, and delete their music. The feature we've added is optional, but it's a great way to enhance user experience. Users will no longer have to worry about accidentally leaving the page with unsaved changes. We'll continue working on the application in the next few sections.